can you please tell us your name and where you're from? I'm sorry, your name and where you're from.
Okay, my name is Oliver Krause and I'm from Heidelberg, Germany, from the Max Planck Institute for Astronomy. And I'm flying here on SOFIA because I have a program on studies of the interstellar medium, which we want to conduct with the forecast instrument. So it's a mid-infrared camera, and what you see with this instrument actually is emission from dust grains. So in the universe, I mean, although most of the material is essentially gas, there's a lot of hydrogen and other atoms. About 1% of the mass is in small dust grains. And so although it's not a lot of material, it's very important because the dust grains, they strongly emit in the infrared. They also absorb the optical, for example. So if you look at the Milky Way, you often see dark patches and dark lanes, and that is because the light from stars behind is absorbed by these dust particles. And then on the other hand, they emit their radiation in the infrared. And so in the infrared, you can easily see how the matter is distributed, and it's not absorbed. So you can look much deeper into dense clouds of dust and gas. So that's what we want to do here with this instrument, and we have a very special program, and that is we are not looking at normal emission of this material, which is usually heated by the radiation field of the stars, but we look at dust which is in the neighborhood of a supernova remnant, which is called Cassiopeia A. It was an explosion of a star about 330 years ago. And what we have discovered actually with the Spitzer Space Telescope in the infrared is that the light of this explosion is still, if you want, traveling through the space, obviously, and then heating up matter, and you can still see that because of the time delay. I mean, you illuminate this material, and then because the speed of the light is finite and the distances are large, but so you have some echo effect. Essentially, you can still see this explosion, and so now by illuminating now these dust particles and in the interstellar medium, you can somehow get a very unique view of the distribution of the material. Because usually if you look into the space, I mean, you just see everything along your line of sight, and it's very difficult to disentangle now the distance you are looking at. And if you have now this emission in a so-called infrared echo, you actually very much know where it is situated, and you can reconstruct actually the three-dimensional structure also. That's the plan here, and I mean that requires essentially that you do time series observations, and we have done some observations earlier with Spitzer, and now we're going to SOFIA. We can continue with this. It's very important because, as you know, probably that the Spitzer Space Telescope is run out of coolant, so it's not any longer working. And with SOFIA, you can now continue these studies, and what you get actually is a kind of a stack of images over time, and that gives you then a three-dimensional picture of the ISM, which can otherwise not be obtained. So that's in short the idea we have for these observations.
Thank you. That was awesome.